here's your quick, let's play around in Scratch. If you haven't figured it out yet, you click down here and oh my God, you have tons of cool things to add to your project. Now, if you let your mouse hover over something like Ben over here, and Ben starts being all movementy, all right? Those are Ben's different costumes, okay? What's a costume? So let me click on Ben, okay? You notice now I got Ben and the cat both on my screen. Well, we've been playing around here with the code blocks, but I just told you we don't like tabs. But if you click up here, each sprite has a costume. And the point of costumes is to create the illusion of movement, okay? If I ask the cat to move like 50 steps, okay? Hey, cat, just move, let's say 50 steps and click on this. My cat moves 50 steps, but that's not real. Come on, that's like terrible. I don't even see his feet moving. So that's the point of costumes. Costumes makes things look like they're moving. Okay, now, if I wanted to, I can go to looks, and you notice right here, I can switch it to the next costume. So if I click on this, oh, but there's a problem. He actually moved 50, right? So this is like, these are just basic things that you can play around with as far as like realizing there's costumes. Now look at Ben. When I go to Ben and click on costumes, Ben's got 4 costumes because Ben can do a lot of different things. So that's one of the first things that's cool. We start off by just making stuff move, but then we want to get our students to start thinking about, well, how would I get the cat to walk across the screen? Like thinking about that now, man, that could take you 45 minutes, right? Wait, how do I get the cat to walk across the screen? So that's the first thing we're going to talk about, all right? Now, the other thing is right next to your sprites, you have backdrops. You have a lot of backdrops, okay? And guess what a backdrop is? It's a sprite. It's no different than the cat. The thing is that it's just the backdrop. So let's scroll down and let's go to Garden Rock because, yeah, I'm just that type of person, okay? So when I click on Garden Rock, you see now everyone's playing in the Garden Rock, but click on your backdrop and you actually have code for it, okay? Now, if you click on backdrop, you could add more pictures and kind of switch, backdrops, because that's one of the codes. Next backdrop, next backdrop, next backdrop. So if I really like this, I could actually choose a backdrop and then choose Malibu Beach instead, okay? And then in my code, I can just say switch backdrop to, and then let's go to Malibu. And when I click on it, it'll switch it to Malibu. So we have sprites that are going to be our characters. We have backdrops. And you can write code and put it in your backdrop. I mean, that's like a cool place. I know there are some programmers who already have text-based coding where I know this. They add sprites to their project and then they do all their coding right here in the backdrop. I mean, they literally write their whole program in there. This really cool Super Mario Brothers project. How many sprites does it have? 1. How could that be? How is that possible? We don't have time to wonder. It's because they actually are using costumes for everything else in the game, whether it's a character, a scene, a plant, right? In the end, when you think about it, geez, there's a lot of repetitive screens in Super Mario Brothers, right? It's just kind of the same thing over and over again. So that's one of the good things about Scratch, and the terrible part is being a teacher. There's no one right way to write a project. So as a teacher, here's the thing. If it works, it works. I mean, it works, it works. And then you have the rubric to see if they hit your parameters. But you guys are going to have to do a rock, paper, scissors project this week. I don't care if you use procedures. I don't care if you use makeup blocks. I say the same thing to my students. If it's plays and it's 2 sprites playing rock, paper, scissors, and when one of them gets to 3, the game ends, I don't care what you did behind the scenes. And that's where the real magic is. You get to see how all these kids think differently, but yet can come up with the same thing. All right, so let's go back to our Scratch platform here. because I can go through our assignments to show you selection, but it's so boring. So let me show you this way. You guys have predominantly been living in what I like to call the Sesame Street blocks, okay? And I have a 7-month-old at home, so if anybody wants to sing Sesame songs with me, hang out afterwards and we'll sing all the songs together. All right, but you did your motion blocks. Well, actually, first of all, let me get back to Ben, because we are not going to, Ben's, you notice like there's limited blocks for your backdrops, but for your regular sprites. So here's all your movement blocks, and you guys have been already familiar with those. You know about your look blocks. It does exactly what it does. It's looking. And some of you played around with your sound blocks, okay? And you know, if you've been playing with your sound blocks, you know here, let me drag this over. So I can play a sound, that's my whistle. But over here it says sounds, okay? Oh, kids love to do this. So this is where you can add more sounds, okay? When you click on the sound tab and you're using a sound block, okay, you can then click choose a sound and we just go off the deep end here. I mean, look, we even have a wacky category, okay? And it's a lot of fun. Yep, I just keep going, bongs, bing, bongs, bongs. All right, so this is where your students can find a lot more sounds if that's what they want to play around with. But the other thing they can do is record their own here as well. So they can upload their own. Even cooler, this is where you can upload the Karate Kid music. So when you do, you know, your Karate Kid project, you can have them playing the Best Around soundtrack in the background. So this is where your students are going to be able to customize the sound by using the sound tab. So what we're going to start learning about now is more about not your events. We're going to call those your yellow blocks. You guys already started playing around with these. You need the green one to get stuff to start. You can do when the whatever is pressed. You can scroll through all these and assign anything to do anything. When the backdrop switches, you can automatically have your code run. That's awesome, right? That's Super Mario there. When you go into the dungeon, that's what they would use. When the backdrop switches to dungeon, have Mario's position, right? Have Mario's position go to somewhere on the screen, usually like down here. All right, if you haven't figured it out yet, wherever you move a sprite, it automatically changes it in the box over here. Look at my go-to. This is quadrant 1, algebra math students. And quadrant 1, my X and Y axis are both what? Positive. So look, my go-to spot is positive 166, 107. If I move down here in quadrant 1, 2, 3, okay? I know that they're both gonna be negative. So this makes coding easy because you don't have to waste your time. If I want, when the program starts, my cat to go here, I would simply go, when the green flag is clicked, cat will go right over there, okay? I still want my cat to move, but I also want him to walk. So let's work with that. We're gonna start backwards here. We're gonna get into control blocks. This is important, write this down. This is selection. All right, my dog's wants to get in on this PD today. And what we're gonna do is we're actually gonna start with our iteration. All right, iteration is a fancy way of saying repeat. These are your iteration blocks. Repeat, forever, repeat until. Those are your iteration blocks. Now, why is this important? Well, first of all, they look like alligator heads, okay? There's a reason for that. We are going to nest other code inside these things. For example, if I wanted the cat to constantly switch its costume forever, I would put it in here and look what happens when I click on it. The cat is now switching its costume forever. It's basically having like a Beavis Butthead sugar high. All right, so that is the power of the forever. Let me drag it out. Now, what you're not realizing yet is there's a reason that these blocks are like this. And that, believe it or not, forever is written slightly more than next costume. It almost looks like next costume is indented. All right, and that's important when we transition to text. All right, now, what else do we notice about these blocks over here? Well, clearly the repeat one is easy. We can repeat it as many times. If this says 10, so it does it 10. All right. But when you get to this repeat until, notice the repeat until has a hexagon. Okay. Any scratch block that's a hexagon is called a conditional. Okay. Conditionals are usually Booleans. What's a Boolean? It's simple. It's either a yes or no question, right? That's a Boolean. So when we see this hexagon, we're going to go straight to our operators. Now, you guys already started playing around with operators. You did your math operators, these guys up here, okay? Now, what do you notice about these math operators? They're shaped like ovals. What did you notice about my repeat 10 over here? Shaped like an oval. That's right. I can take an oval and stick it in an oval. So what did I just do there? I now made it so instead of repeating 10 times, how many times is it going to repeat? Is Nostradamus out there? Anybody Nostradamus? We don't know how many times it's going to repeat because what does this block say? It's going to pick a random number 1 through 10. All right. Well, actually, I want it to be 1 through 50. So now when I put my next costume in here, I'm just going to click on it, but it's randomly going to pick that number 1 through 50. Okay. You can see sometimes it's going fast, sometimes it's going slower. All right. If I want to get, so this is important. Okay. This is called nesting. This is called stacking. We're just going to stack blocks on top of blocks. And hey, guess what? There's no straight rules. There's nothing that says you can't drag and stick a hexagon in an oval. Hey, look at that. That's awesome. So I just want everybody to realize this. You can take stuff and start doing it. And why is that important? That's important because you guys are going to start writing code. You can literally say to yourself, well, all right, like, what do I want to do here? All right, I want the cat to move. All right, well, all right, I want the cat to move forward. Okay, so I want the cat to move. And then I want it to switch to the next costume. So maybe I just want the cat to move 5 and then switch to the next costume. So to get that illusion, I'd have to keep repeating that step, right? Hello, right click. When you right click on stuff, you can duplicate it. Ba-boom. That's right. Let's start making code quickly. Ba-boom. I know I should have showed you this last week. I purposely held out because I wanted to make you guys drag. And you're going to do that to your students too. All right, so now when I click on this, all right, notice it's still a really slow thing because I need to keep clicking on it. I don't want to keep clicking on it. I'm going to stick it right in here. Okay. And now instead I can click on my green flag to bring, hey, look at that. I clicked on my green flag and my cat went back to starting position. And now when I click here, whoa, that looked almost real. Let's go back. Oh, that looked almost awesome. All right. If I really now wanted to do it, let's just do it by one step. Okay, let's go back to the starting point. No, didn't work. No, that didn't work. Maybe I should have increased this over here. Maybe that would have been a better idea. Oh, yeah, that makes it look better. Okay. All right, so he's running across the screen, but this is what iteration is all about, okay? It's about being able to do stuff. So let's go back to these hexagons I told you about, our conditionals. When I tell you that all your students need to know, and I swear, if any of my UT students tell me that you guys can't do the math in this course, it is 9th grade algebra, kids, okay? So you all can do this. I know you can, right? You might not know what Tupperware is, but you know what PEMDAS is. What's PEMDAS, right? Parentheses, exponents, multiply, divide, add, subtract. And then what's the other one? Greater than, equal than, greater than or equal to, less than or equal to. So that's all we're talking about here. So let's take a look. We have greater than, less than, or equal to. We have our and, our or our not. Okay? So these are going to be really important. Now we get fancy schmancy over here. I'm not going to talk about this right now. All right, I'm going to talk about it. Length of is just simply asking you, what's the length of whatever you type in this box? Okay. How many letters is the word apple? 5. because I clicked on it and it told me it's 5. All right, so these are just different things that we can do, but let's just go basic here. So let's just say I want to repeat something a certain number of times. Like I want to repeat it until something happens. Like you're going to be able to say, I want to repeat something, and I'm just going to go to variables. I'm going to repeat, I have a variable here, until the month equals 4. Okay. This is just like what these hexagon conditional statements allow you to do. It's going to allow us, and you're going to see this at the end when we talk about rock, paper, scissors. It's going to allow us to speak code out loud and literally be able to write it here. Okay, so these are our iteration blocks. Now, the next thing that's important that we're going to cover is these other control blocks. These are our selection statements. Okay, selection statement time. Oh, by the way, maybe I just want to save this. Do you guys know you can drag code from one sprite to the other and it goes over there? So you don't have to like code 2 different people. I know. So that's another easy way of doing things. You could just drag code from one sprite to another. Last thing I'm holding out on you on is, if you haven't figured it out, there's a little word at the bottom of your screen. You can barely see it. It says backpack. Click on it. All right. This is going to be Dora the Explorer's contribution to today. All right. You can take code from this project, drag it, put it in your backpack, and you can use that code on any single Scratch project you do for the rest of the course. So now let's just say you guys have code, you figure out how to make that sprite walk really good, copy that code, put it in here. You're going to do your rock, paper, scissors project later. You open up your backpack, even though it's a different assignment, it's in there. The backpack is universal from assignment to assignment. So yeah, that's borderline magic for you, but we pulled it off. So that's going to be a really nice feature. Your students and you should do the same thing. You should definitely drag it in there, and then anything you don't want, you can just drag it out. But it's not really important. You could also right click on it, click delete. Now my backpack is empty again, and I'm going to shut it down.